Okay. In the last lecture, we have discussed about how to design an IIR filter using impulse invariance technique or impulse invariance method, we can call it is. Okay. So what we have done there is we have converted an analog signal to the digital signal by using a sampling technique. That is, we have used a sampling method there. So before going to start with the new topic today, let us understand what are the drawbacks with impulse invariance method, and then we will move towards the next method that is called as bilinear transformation. Okay. Now the question is, what are the drawbacks with sampling theorem? So that is the question to all. What are the drawbacks or problems in sampling theorem? While we are converting an analog signal to a digital signal using a sampling theorem, so what kind of problems or what kind of drawbacks we are going to face? Can anyone tell me? Anybody? Sampling theorem का problem क्या है? Such that we can move ahead. Vaishnavi, can you speak on this part? Vaishnavi Survase. Vaishnavi Survase. Are you there, madam? Roll number 19. Roll number 19. Can you speak on this? Maybe she's having some problem. Okay. Roll number 41 is there? Manju Londe.
Yes, sir.
Madam, can you speak on this? What are the drawbacks with sampling theorem? Can you...
No, sir.
Okay. We have studied the sampling theorem, right? Who will tell me the answer? Who will tell me the answer? Anybody? कोशिश करो यार. You just try to speak something on that part. Roll number 6. Roll number 6.
Yes,
आप
sir.
बोलेंगे मैडम? सॅम्पलिंग थेरम शिकताना आम्ही की प्रॉब्लेम्स सुद्धा डिस्कस केलं होतं. कुठला प्रॉब्लेम येतात तिथं सॅम्पलिंग थेरम मध्ये? Yes. Prajakta, can you speak something on that part? Okay. Vaishnavi Gote.
Yes, sir.
आप बताएंगे मैडम कुछ उस पे?
We no need to consider the harmonic values.
No need to consider the harmonic values. Okay. What else again? सॅम्पलिंग थेरम शिकताना आम्ही एक प्रॉब्लेम पण येतो म्हणून असं शिकलो होतं. तो कुठला प्रॉब्लेम आहे?
Aliasing.
Yes, ma'am.
Aliasing.
Yes, aliasing problem is going to occur with what condition?
Overlapping of signal त्यामुळे सर.
Okay, that is how, why it is occurring.
FS less than twice F max.
Okay, if your value of Fs is less than twice F max, then there is aliasing problem is going to occur. So hence, as we are used in impulse invariance method to convert an analog signal to the sampling, analog signal to digital, analog transfer function to digital transfer function with the sampling method. So that was the main big problem, right? To overcome that problem, that was in the sense like aliasing is the main big problem. To overcome this problem, we are using a bilinear transformation. Hope you understood the problem with impulse invariance method. Alaga Lakshat.
Yes, sir.
Okay, you just write today's title as IIR filter design. Today's title is IIR filter design by bilinear transformation. IIR filter design by bilinear transformation. IIR filter design by bilinear transformation. By bilinear transformation. So this is the title for today's topic. Transformation. You just write under this. In the impulse invariance method, the impulse invariance method, the impulse response of analog filter is sampled. The impulse invariance method, the impulse response of analog filter is sampled, full stop. Is my screen is visible to all?
No, sir.
Okay. Now whether it is visible?
Yes, sir.
Okay. Now what you have written? Analog filter is sampled, full stop. We know that whenever sampling takes place, problem due to aliasing occur, full stop. This aliasing takes place in frequency domain. Full stop. Hence, to design higher frequency filters, using impulse invariance, sampling frequency should be high. Sampling frequency should be high. HIGH, high, full stop. This limits the use of impulse invariance method. This limits the use of impulse invariance method. This limits the use of impulse invariance method to only to, that is TO2, only low pass type of filters. To only low pass type of filters. To only low pass type of filters. Full stop. Next line you write, or else you can take next paragraph. Hence, we will discuss. Hence, we will discuss a different type of mapping, MAPPING, mapping from analog to digital domain. Mapping from analog to digital domain, which overcomes the limitations of invariance method, which overcomes the limitations of impulse invariance method. Limitations of impulse invariance method. Full stop. It is called bilinear transformation. It is called bilinear transformation, and is given by S is equals to 2 by T. S is equals to 2 by T in bracket 1 minus Z inverse divided by 1 plus Z inverse, bracket close, or S is equals to 2 by T, S equals to 2 by T Z minus 1 divided by Z plus 1. So this is what a transformation we are using for this bilinear transformation. Hope you understood why we are going for this bilinear transformation. Yes or no? Hello? Hello? Have you finished the write-up?
Yes, sir.
Okay. Whether you understood why we are going for this bilinear transformation? What is the problem with the existing system? Yes or no? Okay. तो अभी वहां पे analog system transfer function को we have converted into digital transfer function. Here S is used to replace, that is for the analog system, और Z जहां पे आ रहा है उसे हम digital transfer function बोल रहे हैं. ठीक है. Now let us take one example. Just take one example. Or before going to start with the example, we will write steps to convert, like steps to, just write the next title as steps to design digital filter. Steps to design digital filter using bilinear transform technique. Steps to design digital filter using bilinear transform technique. That you just write first one. You may expect this as a theory question also. They will ask you like write a note on bilinear transformation and write its steps to design and filter. Okay. So there you need to write that theory as well as its steps again. So step 1 is from the given specification, find analog frequency, using formula, using formula omega is equals to 2 by t tan omega by 2. Omega equals to 2 by t tan omega by 2. Here, so this omega is, just write, जिसको हम ओम बोल के represent करते, this is the, we are calling it as analog frequency.
अजून काय? किती?
Anchal Sheikh, could you mute your mic, please? Okay, so this we are calling it as analog frequency, and this I am calling it as a digital frequency here, right? You don't get confusion with that part. So here this omega we are calling it as digital frequency, and this I am calling it as analog frequency. So we are going to calculate the analog frequency using this formula it is. Okay, now this is step 1. Then step 2, we just write. Step 2 is, have understood the formula to calculate the analog frequency? Notation pe mat jao. You just remember the things for what we are using. Step 2, you just write, using the analog frequency, find h of s, of the analog filter, of the analog filter it is, we are finding this of the analog filter. Then third point, step 3, select the sampling rate of digital filter. Call it as capital T, seconds per sample. And fourth step is substitute S is equals to 2 by T into 1 minus Z inverse divided by 1 plus Z inverse. Substitute 2 by T, that is S equals to 2 by T, 1 minus Z inverse divided by 1 plus Z inverse into the transfer function, found in equation in step 2, into the transfer function found in step 2. Noted the steps? Can anyone read it? Can anyone read the steps? Anybody? Who will read the steps? Yes. Archana Keskar. Roll number 16. Can you read the steps, madam? What you have noted?
Yes, sir.
जो स्टेप्स लिखे है उसको पढ़ो. Archana, can you please read the steps what you have noted? काय झालं यांना फक्त yes sir जोराने येत आहे. Can any other read it?
Yes, sir.
Okay, कोण 39. Okay, we will give
Sir,
the scope
करते
to
मी.
39. Yes, madam.
Omega by 2. Using frequency, find error phase of the analog filter. Step 3. Select the sampling rate of digital filter, called it as t equal t second per samples. Step 4. Z is equal to 2 by 2 bracket 1 minus Z inverse upon 1 plus Z inverse into the transfer function found in step 2nd.
Hello. Sorry, due to network issue, it was disconnected. Yes, where we are? Am I audible now?
Yes, sir.
Okay. So someone is reading that, no, like 39. Madam, can you proceed?
Yes, sir.
Ah,
Step first. From
okay.
given step first given specification.
Your voice is breaking, madam.
Omega omega
Voice cut होता madam तुमचा. Okay, thank you. Uh, who else is ready again? Who have good connection? Sipra, you want to
Yes,
read
sir.
out, na? Yeah, please.
Step 1 is from the given specifications, find analog frequency using formula omega is equal to 2 by t tan omega by 2, where
Okay, hope you have
omega
understood. Okay.
omega is analog frequency.
Where ohm we are calling it as analog frequency and omega we are calling it as digital frequency. Okay.
Yes.
Then second.
Step 2 is using the analog frequency, find h of s of the analog filter. Step 3,
Okay.
select the sampling rate of digital filter, call it as t seconds
Yeah.
per sample.
Okay.
Step 4, substitute s is equal to 2 by t in bracket 1 minus z inverse upon 1 plus z inverse into the transfer function found in step 2.
Okay. So this is what the steps we need to follow. Right. Now let us take one example. Let's take a question. Take a question. Is my screen is visible?
No, sir.
I think no, it is okay. I'm just sharing now. Okay. I think it's visible now. Let us take a question. Question is apply bilinear transformation. Apply bilinear transformation. Bilinear transformation to h of s is equals to h of s equals to 2 divided by s plus 1 into s plus 2 s plus 1 into s plus 2 with capital T equals to 1 second. With capital T equals to 1 second. With capital T equals to 1 second. And find h of z. Find h of z. Find h of z. So this is what the question. Right? Hope you have written the question. Apply bilinear transformation to h of s equals to 2 divided by s plus 1 into s plus 2 with t equals to 1 second and find h of z. So in this particular example, so no need to go for first two steps. बराबर पहले two steps क्या आपके? What he has given? From given specification, find the analog frequency using the formula. तो यहाँ पे already t दिया हुआ है, so it indicate that you know the value of frequency. तो step 1 का जाना जरूरत नहीं है. Then using analog frequency, find h of s of the analog filter. So already transfer function he has given. So there is no question of going for this second step also. So now we'll go directly to the third step. What is that third step? Select the sampling rate of the digital filter, call it as t seconds per sample. So that is also given, that is t equals to 1 second. The last step is substitute s equals to 2 by t into 1 minus z inverse divided by 1 plus z inverse. So let me write the solution here. Let's write a solution. So if I'm writing the solution here, so what we will write? Right, to convert, use the transformation function. Use the transformation function. What is that? Of bilinear transformation. A bilinear transformation. What is that bilinear transformation function? क्या फंक्शन है अब यहाँ पे? Yes? Anyone? I can write h of z equals to h of z equals to h of s at what we can write here? इसको कैसा करेंगे अभी? If I draw this way line, चलेगा? I don't know. चलेगा ऐसा? छोटा लाइन लेते थोड़ा. My that webcam I could not connect now क्योंकि cables I have connected the mobile. With that I am using the net now. So ये बराबर नहीं आ रहा है. तो कैसा लिख सकते हैं? H of s equals to h of s where s should be replaced by. कैसा लिख सकते हैं इसको अभी? Where s is replaced by. अबे यार लिख सकते हैं इसको. Where s is replaced by. No. Okay, we will write it here separately otherwise. Where s is replaced by the value. Correct. No, this cannot be done. Where this s is equals to what we can write? What is the transformation we are having? वो फॉर्मूला लिखेंगे आप यहाँ पे. हेलो, आ रहा है क्या समझ में?
Yes, sir.
What you are going to write for s? S equals to
2 by t.
s equals to. पेंट में पेन यूज कर सकता हूँ क्या मैं? कैन एनीवन सजेस्ट मी? पेन यूज करके नहीं लिख सकते शायद. और कैन आई गो टू पीपीटी? ओके, देयर आई कैन सी. लेट मी सी इफ आई यूज द पीपीटी. Can I use the PPT? No, I cannot. ठीक है. S equals to what you can write? 2 by t into 1 minus z inverse divided by 1 plus z inverse. Okay. So in that case, what we can write for the above equation? ऐसा लिख सकते हैं? कोई बताएंगे मुझे? how you can write. So h of s equals to, we can write it as, ऐसा लिख सकते हैं, no, cannot. Why? You just try for that. Within 1 minute, I will back again. Let me bring the cable. Yeah. आता कनेक्ट केला मी, आता आलं का? ओके. Hello, am I audible?
Yes, sir.
Okay. Now, let's move to this part. So what we have written here is h of z equals to h of s, where this s is replaced by the value s is equals to 2 by t into 1 minus z inverse divided by 1 plus z inverse. Okay. So therefore, what is our given transfer function? H of s is equals to, is given as by, is given as 2 divided by s plus 1 into s plus 2. This is given. So here you need to just replace the value, or else this equals to, I can write it as, what is the value of t? It is given in the question. तो t का वैल्यू क्या है यहाँ पे? 1. तो यहाँ पे क्या रहेगा अभी, like 2 into 1 minus z inverse divided by 1 plus z inverse. Okay. So now this becomes 2 divided by, yes, we are replacing it by the value 2 into 1 minus z inverse divided by 1 plus z inverse into, sorry, this will be like plus 1 again, plus 1, close the bracket. Then second part is, again it is 2 into 1 minus z inverse divided by 1 plus z inverse plus 2 it is. Hope you understood this step. Any confusion here? Hello?
No, sir.
Okay. Then further, if you simplify this, what we can write again? इसको simplify कैसे कर सकते हैं हम? So this I can write it as simply 2 divided by, this is 2 into 1 minus z inverse plus this 1 plus z inverse, I will take it this side, 1 plus z inverse divided by 1 plus z inverse. ठीक है. This is again close the bracket. Then the second term is again, it is again 2 into 1 minus z inverse plus 2 into 1 plus z inverse divided by 1 plus z inverse I can write. Okay. Then just close this complete bracket. Then can you simplify this further? So actually this divide will be complete it is. So यहाँ पे ये complete divide होगा, यहाँ पे भी ये complete divide है. Okay. Now if you further simplify this, what you will get? If I move to the further step, so what I can write is next again h of z equals to, it can be written as h of z equals to, तो यहाँ पे अभी 1 plus z inverse और 1 plus z inverse है, so it can be written as 1 plus z inverse square divided by 2 minus 2 z inverse plus 1 plus z inverse. Then the second bracket is again 2 minus 2 z inverse plus 2 plus 2 z inverse. Okay. So this equals to again, it is 1 plus z power minus 1 square divided by, what we can write further? This is 3 minus z inverse. और ये कितना लिख सकते हैं हम? What I can write for this? Four plus और माइनस प्लस z इनवर्स लिख सकते हैं यहाँ पे. Or else further if you simplify this, you will get the final answer as कुछ तो गलत हो रहा है ना यहाँ पे. Okay, so this is 2z inverse. This 2z inverse and this 2z inverse cancel. Only this will be 4. So this is what the answer we are getting, like z plus 1 plus z inverse square divided by 3 minus z inverse into 4, or simply this equals to, we write it as final answer as, which will be equals to 0.166 into 1 plus z inverse square divided by 1 minus 0.33 z inverse it is. Right? So this is what the final answer. So this is the way how we are converting analog system to the digital system by using bilinear transformation. Understood? Any difficulty here? Any difficulty? Am I audible?
Yes, sir.
Any problem in understanding the question?
So that numerator 2 is remaining to write.
Which one?
In black color you have written in numerator 2, but in blue colors formula it is missing, sir.
Okay. Okay, this 2 is also there, na? Okay, thank you. That is 2 is there. 2 into 1 plus z inverse. So you just further simplify that. So here this will be like 2 into 1 plus z inverse square. Still anything remain there? No. So this is the final answer, like 0.166 1 plus z inverse square divided by 1 minus 0.33 z inverse. Can you try one more question? Can I go to the next question?
Yes, sir.
Please take one more question. Determine h of z. Determine h of z that results when the bilinear transformation is applied to that results when the bilinear transformation is applied to h of s is equals to h of s is equals to s square plus 4.525 divided by s square plus 0.692s plus 0.504. So this is the question. H of s equals to s square plus 4.525 divided by s square plus 0.692s plus 0.504. Can you try for this? You just try this. Let's see. The same method you can apply. So till that, I will take the attendance again. Roll number 1, continue with your attendance. Number 1 is there. Two, 3,
Present, sir.
4,
Present.
5,
Present, sir.
6,
Yes, sir.
7,
Yes, sir.
8,
Yes, sir.
9,
Present, sir.
10,
Present, sir.
11,
Present, sir.
12,
Present, sir.
13. 13 is there. Monica Shinde. 14,
Present, sir.
14.
Present, sir.
Okay. 15,
Yes, sir.
15, 16.
Yes, sir. Present.
Okay. 15 present. 16.
Present.
Okay. 17. 17 is there. 18, 18, 19,
Present, sir.
20,
Present, sir.
21, 21,
Present, sir.
22,
Yes, sir.
23, 23, 24,
Present, sir.
25.
Present, sir.
So who have given attendance, don't put it in the chat box. If you are having any problem, then only put it in the chat box. 25 is there. 26,
Present, sir.
27, 27.
Present, sir.
Okay. 28, 28, 29, 29, 30,
Present, sir.
31,
Present, sir.
32,
Present, sir.
33, 33, 34.
Present, sir.
Okay. 34, 35, 35, 36,
Present, sir.
37,
Present, sir.
38, 39,
Present, sir.
41,
Present, sir.
42,
Present, sir.
43,
Present, sir.
43 is there, 44, 44, 45, 45, 46,
Yes, sir.
47, 47, 48, 48, 49, 49, 51,
Yes, sir.
52,
Sir.
52, 49 is also there. Okay. 52 is there. 52, 53, 54, 53 present. 54, 55, 55, 56,
Yes, sir.
57,
Present, sir.
58, 58, 59, 60, 61, 62, 63, 64,
Yes, sir.
65,
Yes, sir.
66, 66 is there. 66, 67, 67, 68,
Present, sir.
69,
Present, sir.
70,
Present, sir.
71,
Present, sir.
72, 72 is there. 73,
Yes, sir.
74.
Yes, sir.
Okay. If anybody is having the problem, they can put in chat box. Okay. So what is the answer? Anybody has got the answer? Anybody has got the answer for the example? 13 you were present. Don't worry, madam. Okay, we'll stop the session here. You carry on that example. Tomorrow we will have a discussion on that part. Thank you. बोला की. अच्छा आम्ही ते पण आम्हीच करायचं. ठीक. या तुमचं. आपण यायचं का? कोण येणार?